The ancient Greek philosopher Democritus theorized that all that existed were atoms and the void, and all material things were comprised of these tiny bits of matter called atoms. Today, the essential features of this theory continue on, and many people believe we're entirely comprised of nothing but subatomic particles, which are thought to be tiny bits of matter that are the fundamental building blocks of all things. But have you ever asked yourself, what is a particle? Are particles fundamental bits from which all things are built? Or has modern science revealed that the subatomic world is less material than we realize? A view held by many today is physicalism, which is sometimes equated with materialism. It essentially is the belief that everything that exists, every substance, is a physical substance, and every substance only has physical properties, and so every event must have a physical cause as well. On this view, all that we are reduces to physical objects or substances. In the past, and many laymen still today, believe that all things reduce to tiny bits of matter we call particles. However, this view has been challenged by modern scientific research, and with the rise of quantum field theory, a better understanding of matter is emerging. Physicist Dr. Nigel Cundy points out quantum field theory is the underlying fundamental theory that describes all of physical reality, and which everything else builds upon. It is a theory that combines quantum mechanics and special relativity, and can be seen as an extension of quantum mechanics that covers the analysis of systems with many particles and fields within a uniform theoretical framework. In other words, it is a theory that describes the operations and actions of the underlying subatomic world. However, in quantum field theory, particles are not perceived to be tiny balls or bits of matter like we traditionally think. That view of particles is an artifact of previous theories that are no longer viable. Instead, particles are better understood as excited states of quantum fields, and are completely described mathematically as ripples within a quantum field, not little bits or balls of matter that are bouncing around in space. Cundy says, "The classical imagination, which underlies modern philosophy, has failed us. We still think of particles in modern physics, but we no longer mean the same thing by the word that people like Newton and Boyle did. Instead, he defines a particle as a metastable state, which carries a definite energy and momentum, and which corresponds to a particular set of creation and annihilation operators. A particle is thus an energy, momentum excitation of the underlying matter field. Note that this definition is contrary to the classical definition of a particle, which implies an element of spatial location." Likewise, Wouter Schmitz says, "Particles are actually waves in different types of fields. This goes for all the particles that we are made of. We are all just made of waves in a field. The vacuum is not something empty, a big nothingness, but contains fields that are waving all the time. What looks to us as a billiard ball on the billiard table is actually a bunch of waves moving from the cue to the pocket." In other words, there's nothing we know of a particle in quantum field theory that is not a mathematical description of a wave equation. The old view that a particle is a tiny, indivisible bit is not part of quantum field theory. Physicist Eliano Pessa notes within quantum field theory, defining exactly what particles are can be difficult, and various interpretations can follow. However, he points out the possibility of a particle interpretation of quantum theory has for the most part been ruled out, and a new understanding of particles must be implemented. The solution entails the idea that particles should be considered as merely the byproduct of interactions between quantum fields and an environment. They are emergent mathematical constructs of underlying fields. A particle is nothing but an effective field description of a complicated dynamics coupling the environment and its fields. The solution we have sketched above entails the disappearance of the hexiatus of particles, which are reduced to mere auxiliary constructs, useful for practical purposes, but in turn making reference to deeper constructs. For these philosophers, the problem now becomes, what are these constructs? Thus, particles are best understood as emergent mathematical constructs from underlying fields. Many modern physicalists who are aware of these issues try to bypass this and argue everything reduces to quantum fields, which would be the basis of all matter. But with this in mind, the next question is what is a quantum field? And this can be more difficult to define, and quantum fields do not appear to be underlying objects or fundamental material substances. And the more we try to understand the basis of all reality, the more abstract things become. Wouter Schmitz says, a field is anything that can assume a value in every part of spacetime, and he says that fields are that which give rise to particles. Fields seem to be more mathematical than concrete. David John Baker demonstrated that many of the problems particle interpretations have also apply to field interpretations. Wave-functional space is equivalent, in a mathematically rigorous sense, to the Fock space that represents states as particle configurations. This has the consequence that two of the most powerful arguments against particles are also arguments against such a field interpretation, and this in turn indicates that field interpretations are not, as many have assumed, a readily available alternative to particle interpretations. If the particle concept cannot be applied to quantum field theory, it seems that the field concept must also break down as well. Now, his paper is complicated, but in a nutshell, what he shows is that there are many mathematical problems in saying quantum fields are fundamental. Baker concludes, it seems that in many ways fields and particle interpretations must stand or fall together. Particles and fields essentially seem to be representations, so just appealing to fields to escape the problems that show particles cannot be fundamental doesn't work, because a lot of the same mathematical issues come up. Meinard Kuhlmann notes that physics lacks a coherent account of fundamental issues, such as the definition of objects. Quantum field theory doesn't really tell us what substance quantum fields are. Instead, we only get an understanding of structures, relations, activities, and properties. He says, it sounds like having a marriage without spouses. And he also notes, a quantum field instead assigns abstract mathematical entities, which represent the type of measurements you could conduct, rather than the result you would obtain. Some mathematical constructs in the theory do represent physical values, but these cannot be assigned to points in spacetime, only to smeared out regions. It is not at all clear what a particle or field even is. As Kuhlmann notes, quantum field theory works without any relation to a fundamental substance that gives rise to fields and particles. Whatever matter is, it is not made of matter. Things get even stranger when we talk about the wave function of a particle. Quantum mechanics shows us in the absence of measurement on a particle, there is no discrete physical particle, but instead something called a wave function, which is just a mathematical probability of where the particle could end up. However, prior to measurement, there are no hidden variables that indicate the particle was already there and just waiting to be found. All that exists is the wave function, not a material particle. The key to understanding what is happening is that matter doesn't exist as a wave of energy prior to observation, but as a wave of mathematical potentialities prior to observation. Bruce Rosenblum and Fred Kuttner say it like this: the waviness in a region is the probability of finding the object in a particular place. We must be careful. The waviness is not the probability of the object being in a particular place. There is a crucial difference here. The object was not there before you found it there. In other words, prior to measurement, experimental results in the mathematical formalism of quantum mechanics imply there is no physical particle. Measurement causes the wave function to collapse to the physical particle, but nothing was physically there prior to measurement. Werner Heisenberg said, "The conception of objective reality of the elementary particles has thus evaporated, not into the cloud of some obscure new reality concept, but into the transparent clarity of a mathematics that represents no longer the behavior of particles, but rather our knowledge of this behavior. But if there is no scientific evidence that the underlying subatomic world is material, then what even is matter? In other words, if all we can induce is particles ultimately reduced to mathematics, then the evidence indicates that our material reality is a construct of underlying information. Science was once thought to point to physicalism or materialism, but instead, it has revealed the inadequacy of these beliefs. It is fitting that physics, the science that gave rise to materialism, should also signal the demise of materialism. During this century, the new physics has blown apart the central tenets of materialist doctrine in a sequence of stunning developments. First came the theory of relativity, which demolished Newton's assumptions about space and time. Then came the quantum theory, which totally transformed our image of matter. This is also supported by the holographic principle, which suggests the entire three-dimensional universe can be stored as two-dimensional information. The way it is explained is hypothetically, if something were to fall into a black hole, all the information of that object would be imprinted on its surface like a 2D image of what was once there. This was derived from the discovery that when something is added to a black hole, the volume doesn't change, but the black hole's surface area does change. In other words, the information of a three-dimensional object is encoded on the two-dimensional surface on the outside of the black hole. However, what is derived from this is the inference that all the information of the 3D universe could be like a hologram of this two-dimensional information, because the physics of black holes is similar to the physics of the singularity before the expansion of the universe. So the Big Bang and the expansion could be modeled in a way that is like a holographic projection of underlying information. In other words, this would mean all the matter of the universe is an informational construct, not built by tiny bits of matter. Leonard Susskind says, "The three-dimensional world of ordinary experience, the universe filled with galaxies, stars, planets, houses, boulders, and people, is a hologram, an image of reality coded on a distant two-dimensional surface." Thus supporting the notion the three-dimensional universe is an informational construct, not composed of fundamental material particles. What particles actually seem to be is constructs of mathematical information, which interestingly enough correlates to how we experience the physical world. It was Bishop Berkeley who argued that the physical world is nothing more than mental experiences or information, meaning anything perceived in the physical world is not a real substance, but a collection of mental properties. So think of what you experience. You experience properties. You experience mental things like colors, sounds, textures, forms and feelings, etc. What you experience are properties, not the objects directly. An idea that goes back to David Hume is something called bundle theory, which is the idea that physical objects just exist as a collection of properties, and if you remove the properties, there is nothing left to describe an object. So think of an apple. You can describe it as round, red, hard, and tasty. However, if you remove all the properties, what are you left with to describe this object? Susan Schneider says, "Pure property ontologies need to take physical objects as metaphysically derivative, even objects that physics regards as fundamental. Objects are instead bundled out of properties, or they are properties." To elaborate further, a color is a mental experience, which cannot be reduced to something physical. The scientific explanation of how we see color is that an electromagnetic wave hits the eye, creating a biochemical state, which then creates a neural pattern in the brain. But nothing in this transfer of mere information is the experience of color. Color is purely a mental experience, not a property that exists without a mind. If you touch water, you experience wetness. But wetness is only a mental sensation. Wetness only occurs when a mind experiences water. The same applies to taste sensations. Sugar doesn't taste sweet unless there is a mind there to experience it. Thomas Nagel says, If a mental event really is a physical event in the sense and nothing else, then the physical event by itself, once its physical properties are understood, should likewise be sufficient for the taste of sugar, the feeling of pain, or whatever it is supposed to be identical with. But it doesn't seem to be. It seems conceivable, for any physical event, there should be a physical event without any experience at all. Experience of taste seems to be something extra, contingently related to the brain state, something produced rather than constituted by the brain state. So it cannot be identical to the brain state in the same way that water is identical to H2O. Todd Burris and Trent Doherty present a similar argument, called the problem of positive properties. When we say an object is physical, there is no way in which we describe it where we refer to it as an object without reference to our mental experiences or properties. We always describe physical objects in ways that are mind-dependent. So we lack positive properties that indicate the object is a distinct physical substance. A physicalist needs to show there is something there beyond the mental experience. What intrinsic qualities do physical objects have that are intrinsic to the objects themselves? Physicalists need to show there is something to the alleged mind-independent objects beyond their extrinsic, relational, or purely formal properties. As they put it, perhaps none of the familiar properties of corporeal substances characterize bodies as they are in themselves. Perhaps all their properties are merely formal, extrinsic, relational features. It could be that there is nothing that a physical object is like in itself. Perhaps there is nothing more to such things than the relational features they bear to other things, particularly perceiving minds. Once the possibility is raised, it can take on a default position in that one realizes, in raising the possibility, that we are nearly devoid of reasons to think allegedly extramental entities have positive properties. All of what we experience is a world of mental properties. So why posit physical substances beyond our mental experiences if such substances are not necessary? We experience a mental world, not a physical one, and we do not need to posit anything beyond the mental properties to understand the world around us. In other words, all things physical appear to be mental properties or information. Keith Ward puts it like this: any physicist will say that brains are mostly empty space, in which molecules and other strange particles buzz about in complicated ways. It seems as though physical objects, when not being observed, have no colors and no sounds, smells or tastes either. Sounds like colors are not physical events. Neither are smells, tastes, or sensations. Things do not smell like, taste like, or feel like anything when nobody is smelling, tasting, or feeling them. The physical world, it seems, is totally vacuous. No colors, sounds, smells, tastes, or sensations. What on earth is left? Susan Schneider applies this same logic to the subatomic world. As we noted earlier, in quantum field theory, particles are completely described by mathematics, without any reference to an entity. However, if the only way we can differentiate an electron from a proton within physics is mathematically, then why isn't the mathematical equation part of the makeup of the electron and the proton, the same way redness is a property of an apple? Much like the idea of bundle theory about physical objects, if you strip away the mathematical description of a particle, you're left with nothing to describe it. So why should we posit real physical entities when philosophically there is nothing there but the mathematical information, which, just like the physical properties, can be explained purely as mental information? As Schneider says, physics is highly abstract, and the physicalist lacks physically kosher truth makers for its claims. Physics is not physicalistic, if you will. In short, fundamental physics is mathematized physics. As Timothy Williamson has remarked, what, for a start, is the natural world? If we say it is a world of matter, or the world of atoms, we are left behind by modern physics, which characterizes the world in far more abstract terms. Meinard Kuhlmann says, what we call an electron is in fact a bundle of various properties or tropes, 3 fixed essential properties, mass, charge, and spin, as well as numerous changing, non-essential properties, position and velocity. A particle is what you get when those properties bundle themselves together in a certain way. Thus, all of matter can adequately be explained as mental information. Now we must ask, if material particles are not the fundamental basis of reality, then what is? The solution is pretty obvious at this point. If matter can be reduced to mathematical abstractions and mental information, then the basis of the physical is consciousness. Instead of matter creating mind, the evidence implies the opposite. Mind creates the appearance of matter. Such an idea has already been proposed by cognitive scientist Donald Hoffman. Instead of matter being the basis of all consciousness, consciousness is the basis of what we experience as matter.
Green also concludes that, he says in his recent book, The Fabric of the Cosmos, that space, like electrons, comes in discrete, indivisible chunks. Space and time are pixelized. We need that to get our ultimate theory of space and time. And the very fabric of space and time is composed of more fundamental spaceless and timeless entities. But he doesn't know what they are. I have a proposal. Those spaceless and timeless entities that they're looking for are in fact conscious agents.
So what we see in modern science points away from physicalism and is better explained by an idealist perspective. Mind is fundamental and matter is emergent. Thus modern science was once thought to point to physicalism. The universe was cold and dead. Meaning and purpose were mere subjective constructs. Humans were biological robots, merely the product of atoms. But beneath the atoms, the world revealed itself to be more abstract, mental in nature. The fundamental particles, once thought to be the basis of reality, were revealed to be constructs of a mental reality. The old Cartesian notion of humans being ghosts and machines might be dead, but not because there are no ghosts, but because there are no machines.